Welcome to Brain Vision.
So ideal gas law question: if 3.8 meters cubed of gas is initially at standard temperature and pressure, is placed under a new pressure of 3.2 atmospheres, the temperature of the gas rises to 38 degrees Celsius. What is the volume? So we're going to start from the ideal gas law. So P, pressure times volume, equals number of moles times the Boltzmann gas constant, nRT. Now we're going to simplify this in terms of for what we need this for. So we have the initial, so P1 equals P1 V1 is equal to nRT1, because we're not changing the amount of gas here, so nR a constant here, and P2 V2 is equal to nRT2, and we're going to call this equation 1 and equation 2. And we are going to do 1 divided by 2. So from this we get P1 over P2 multiplied by V1 over V2. That dot's just a multiplication sign. In more advanced math, you just use a dot instead of a multiplication sign. Is equal to T1 over T2. And that T isn't so clear. Let me just redo that. Is equal to T1 over T2. And so we are going from pressure 1, which is at 1 atmosphere, and pressure 2, which is at 3.18 atmosphere. So we don't need to do any unit conversion because these are just ratios. We're just interested in the ratios between the different volumes here. So plugging in our current knowns, we have 1 over 3.12 multiplied by 3.8 meters cubed divided by V2, which we want to calculate, is equal to so the T1 is equal to 273.15. So this is absolute zero, 3.15. And then T2 is simply 273.15, add on 38, which gives us 311.15. And making V2 the subject of the equation, we have that V2 is equal to 3.8 times 311.15 divided by 3.12 times by 273.15, and that, plugging that into a calculator, we get that V2 is equal to 1.39 meters cubed. And as you can see, this isn't quite align with the question in the answer in the textbook. The answer in the textbook is 1.34. Now, what I think they've done is I think they've calculated N and R here and made some rounding errors, because if you round to 3 significant figures, hence the discrepancy. But this is the more elegant way through the solution. There's less calculation. Yeah, it's just better. So yeah, that's how you compare.